Now we are going to the next problem. I have written already here. The problem is if x is equals to x to the power n, that means n is any kind of number. Now we want to identify the differentiation of this x to the power n by using the same first principle. So how to do that one? Dy dx, again I am writing here, is equals to limit h tends to f of x plus h minus fx whole divided by h. That means f of x means this one, so x plus h means just you have to replace this x by x plus h. So limit h tends to 0, x plus h whole to the power n minus x to the power n whole divided by h. Now from this what happens, we can be able to write it down like this: x to the power n, we can take common from this x to the power n, then 1 plus h by x, like this. So if I take common from this, we can be able to identify the final value. So x to the power n plus nc1 x limit h tends to 0, x to the power n plus nc1 x to the power n minus 1 into h plus nc2 x to the power n minus 2 into h square, like this. That is the binomial expression of x plus h whole to the power n minus x to the power n and whole divided by h. So what happens, x to the power n and this x to the power n crossed out. Ultimately whatever be the value, we can take from this numerator h as common. Limit h tends to 0, if I take h common, you will have nc1 x to the power n minus 1, h we have taken common, okay, nc2 x to the power n minus 2 into h, then plus last one h to the power n minus 1. That is the total binomial expression we are getting after taking out from this particular expression h, and denominator there is also another h. So finally again h and h crossed out. As we have said earlier, we have to write as h tends to 0, then h must not be equal to 0, so this denominator value should not be 0. So finally what happens, after this, if I put the value of this h is equals to 0 anywhere in the equation, then here only nc1 x to the power n minus 1 should be there, and all the other terms of the numerator must be equal to 0 when we will put the value of h as equals to 0. So finally the expression should be nc1 x to the power n minus 1. What is nc1? Most probably we know, or otherwise we will when we will go to that part of the binomial equation or theorem, we will discuss this one. That means factorial n by factorial 1 is basically this 1 into n minus 1 factorial. That is the real expression. NCR means factorial n by factorial r into factorial n minus r, and x to the power n minus 1. So factorial n means n into n minus 1 factorial, and lower term n minus 1 factorial, x to the power n minus 1. So finally what happens, these two crossed out, that becomes n into x to the power n minus 1. So we have to remember what is that. That means if there is y is equals to x to the power n or if x is equals to x to the power n, then the final value of the differentiation of that x to the power n must be equal to n into x to the power n minus 1.